and just recorded like 5 minutes without audio. So we're back with audio. I'm excited to teach you or show you or learn with you about shouldComponentUpdate and how that might transfer to React hooks in functional components. Luca, you saved my butt on that one. You were like, hey, there's no audio. And I was like, oh my gosh, I've been talking to myself for the last 5 minutes. So basically, we have set up a little application here that has a really expensive component. And this expensive component is looping through, how many times is it looping through? Let's see, there's a million. A billion? I think it's looping through 1 billion times. And that's a lot of work to do right now for this little expensive component. It could be doing something a little more expensive, like if we were rendering a huge subtree in React and there was a bunch of work going on, or we were rendering like a ton of DOM nodes. And maybe we could actually do that. That might be easier. But in fact, let's do that. I think that's going to be a better visual representation of what we want. So to do that, we're going to make an array of stuff. We'll call it things. And it's going to be a new array of, let's say, 10,000 things. We're going to map over it. And we're going to return I. And let's just log out things really quick to make sure that we actually have a big, nasty array. Holy crap, we do. We have a big, nasty array. Okay. And then we're going to loop over that array in our component. So we're going to say things, map thing, and we're going to return a new div with the thing in it. Okay, that's an expensive component right there, because that's just rendering a lot of DOM. You probably run into this with tables and stuff. If you've ever done like long lists or tables, and there are tools to help you do that. But really, we just want to simulate a component that's really expensive. And we want that component to change basically anytime that we increment this counter that I've set up. So we're using a useState hook right here. We've got a count. And every time that we increment that, it is re-rendering this expensive component with the count. And I think what we could do is we could use the count in our props here. Const count equals this dot props, and we could do I times count. So then as we increment, you can see it's taking a long time to update because it has to basically re-render and reconcile all of the changes to these 10,000 DOM nodes that we've set up. Sorry, 100,000 DOM nodes that we've set up. Even more, I guess. No, it's just 10,000. Oh, duh, that's because we're multiplying. Okay, so you can see it's pretty expensive. And in fact, let's add that. Let's go to up to 100,000. So you can see even just building that first list took a while. If we increment, then it takes about 3, 4, 5 seconds to update. So this is a very expensive component. And if we were in the old world of classes, we could implement this lifecycle method right here called shouldComponentUpdate. And we could basically say, let's just console log out next props and this dot props. In fact, let's do this dot props first. So as we increment, it's taking in this next props that says it's count 1. So the new props is count 1 and the old props is count 0. So we could do some comparison stuff here, and we could say if this dot props count is greater than 3. In fact, we'll just do next props. So we'll say if next props dot count is greater than 3, return false. Otherwise, return true. Basically, we're telling our component, if the new props coming in, if the count is greater than 3, then just don't update at all. So we're going to have an expensive update here, another one here, and then another one here, and then this next increment, it's not going to update because our next props count is greater than 3, and so we're just saying we are opting out of updating at all. And to make that a little more obvious, why don't we do a divisible by 2? So when it's divisible by 2, it's not going to update. So you can see every other click, it's updating. Now that's pretty contrived, but you can see how that'd be useful if you know that whatever work you're doing in here or whatever things you're doing underneath these components or inside this component doesn't need to change unless your props are changing, then you could use shouldComponentUpdate here. Now some of you might be thinking, oh well, couldn't you just use pureComponent? Yes, you could. Like, you could just get rid of that, and you could say, let's see, pureComponent. Let's do this. Let's create another state right here. And no, pureComponent. I'm trying to think of a good example for you guys. So if we were to move this to a pureComponent, extending the React pureComponent class, then basically what it's doing is it's always comparing the old props to the new ones shallowly, and if any of the props change, then it's re-rendering. But see, that doesn't give us a whole lot of control. If we were using shouldComponentUpdate, basically shouldComponentUpdate means, you know what, props aren't enough, just like a shallow comparison of props isn't enough. We need more control. Because if all you want to do is just say, you know what, memoize and compare the props, pureComponent is going to be super easy to use. But shouldComponentUpdate usually comes into play when you need to calculate some state from your props. You need to use derived state, or maybe shouldComponentUpdate actually involves the next state of your component. And this is something that shouldComponentUpdate and even React Memo that we're going to talk about in a little bit cannot handle, is handling the state. So what we're going to do is we're going to convert this over to a functional component. So if we just get rid of this, we say function expensive component, and our props are going to come in right here with count, so we don't need that, or a render. And then we're making the array of things and we're looping over them every single time. So this is still a very expensive functional component. Now, again, we have been given a cool tool from the React team called React Memo, which is basically pureComponent for function components. And you could do this. You could say const expensive component equals React Memo. And this could just be like an anonymous function, but I guess we're going to call it the same thing actually. And let's see. So what that does is it's basically turning this component into a functional, or into a pureComponent. So if any of the props change, it's going to re-render. Which, interestingly enough, if we do like another state right here, let's have 2 buttons. Let's do a toggle right here, and we're just going to do not old. We'll just call this toggle, and we're going to do on is going to be the toggle value, and we're going to have toggle be the setter. So let's see, on to string, and let's start it with false. So you can see as we're toggling this toggle right here, this component, this expensive component, is not trying to update because none of its props are actually changing. So the DOM is very responsive because this work is not being done unless count actually changes. And the second that we increment, it's going to change. That's really cool, except for that's not really shouldComponentUpdate. Technically, that's just pure component. shouldComponentUpdate is like a really special use case where usually when you use shouldComponentUpdate, it means that you're relying on some internals of your component to determine whether something is going to be expensive or not. So really, just a kind of a blind memoization isn't really going to be the answer here. In fact, what we could do is we could say, let's put this toggle inside of our expensive component. I think this is going to make it so that we can understand how this works a little bit easier. And look how easy it is to move hooks around. That's why hooks are amazing. We just moved the hook straight up into the expensive component. So now, let's see, let's do this. Just to make sure that we know this is the expensive component. Put that right there. And then we'll put a little break under here. Okay, so we're incrementing and it's still taking forever, right? So what if the expensive component's toggle could determine whether it was going to update or not? In fact, let's just do this. Let's turn this toggle into the shouldComponentUpdate. We're going to default it to true, okay? And when it's on, we want to update this component. But like this is where I struggled for a little bit to think about how to do this. And then I had an awesome aha moment reading through the React hook docs. React hooks reference. So API reference. In fact, it was actually in the FAQ. I want to take you through this. When you read about this first, you're going to be like, oh, well, duh. Of course you can. Of course you can do that. But then I didn't really draw the connection to shouldComponentUpdate until later. So there is, how do I implement shouldComponentUpdate? Now see, out of the gate, they're saying, oh, we'll use React Memo, right? And so most people are like, oh, okay, use React Memo. And that's really great, but then I love this right here. React Memo doesn't compare state because there's no single state object to compare. But you can make children pure too, or even optimize individual children with useMemo. So this one right here, it's what they're doing is they're using memoization. They're using the useMemo hook to basically implement change detection, which is basically all shouldComponentUpdate is anyway, right? They're using change detection to see if they should actually update a specific element. Well, what if this was our main render inside of here? Let's just grab this right here, straight out of there. Bring it over here, and let's just say, let's just call this children. Or we'll call this rendered, I guess. And then we're going to use memo, and let's just take all of this stuff that we have, and let's just put it inside of here, just like that. And then we're going to return rendered. Now A is not defined, and use memo. Now see, we're not using any change detection on anything, so it's never updating. But really what we could do here is we could say, you know what, whenever, let's see, if we put the count inside of this memoizer, we're still back to square one, where if the count changes, it's going to recompute this stuff right here. And it's still looping through things. You know what, let's do this. Let's move things inside of here because that's what's expensive. And let's return this div. So now we're only recomputing the things inside of the memo. So when we increment, it's saying, okay, the count changed here in this memoizer, so we're going to recompute this thing. But then we're back to square one, right? What we really want to know is the toggle on or not, and has the count changed? So, and we don't want to compute these things unless, we don't want to do this computation unless it's actually happened. So I think one way we could do this is, and this is kind of where we're getting into discovery. Like I haven't thought, or I haven't really coded beyond where we're at right now, and so hopefully we can all learn together right here. My first idea would be to create a memoizer for shouldUpdate. So we're going to say shouldUpdate, and we're going to say React use memo, and whenever, and let's see, we're going to say return, we're going to say return on. And how are we going to do this? Let's see. We have a function shouldUpdate. Well, when toggle changes, we want to make sure that we're updating shouldUpdate. And shouldUpdate should only be use memo. How are we going to do this? So we only want to run this code when things have changed. So I guess, can we use, if the toggle changes and if the count changes, then we're going to run this memoizer. And in fact, I feel like we don't need two of them here, so we're just going to move this stuff down here. So when the toggle or the count changes, we're going to update. So toggle false, toggle. When the toggle changes, it should recompute. Oh, that's because we have toggle on there and not on. So now, when we toggle, it's not doing too much work because it's not, let's see, let's do this. Let's put the thing with the toggle, let's see, on toString. So now it's expensive even when we do the toggle, but the toggle, really these things, the toggle should not be inside of this component, really, is what it is. In fact, we should be returning something regardless right here. Like we should have kind of a wrapper with this expensive component, and the toggle should be sitting right here. And these should be things. Yeah, see, this is feeling more like the example from the React hooks documentation. And really, we're going to just be rendering things right here. And things should only, things is going to update when on changes. And see, we can't do conditionals right here. How do we do that? How do we do conditionals in here? Because you can't like pass a function in this array, can you? Like use memo, memoized value, remembering the previous computation. Node calls compute expensive value AB, but if the inputs AB haven't changed since the last value, use memo skips calling it a second time and reuses it. Well, we can't really pass a function right here that says like, So I do think we need another memoizer. And I think what we could do is we could say, like we could make some state here and just start it at 0. This is kind of naive, but let's just try it out. And let's just call this like memo ID, set memo ID. And let's say instead of when on or count changes, we just want to change, we don't want to recompute things when the memo ID changes. And then we're going to say const, or no, we'll say shouldUpdate. shouldUpdate React use memo. And then in this function, we're going to be relying on the on and the count. And then what we're going to return is we're going to say memo ID. In fact, this isn't a memoization. What this is this is an effect right here. And we're going to have this memo ID. We'll just call this shouldUpdate. Set shouldUpdate. This isn't shouldUpdate. This is just an effect. When on or count changes, we're going to run this effect. Basically, we're going to say if the toggle is on, then we're going to say set shouldUpdate old plus 1. Effect is not a function. Use effect. Okay, this is really weird. Like I'm in unknown territory here, you know. So let's see. Expensive component. Let's put this toggle on a new line so it's not bugging me. We're incrementing it. And I'm going to turn it to false. And it's not. Now when I turn it to true, it recomputes again. Okay, let's just, what is going on here? This is interesting. Because the old shouldComponentUpdate lifecycle used was a lifecycle hook, and it gave you all this information about previous props and state, but it was a function. You could return true or false, and it would run every single time. So really what this is this is an effect that runs every single render. It runs after every single render. And I think that's the biggest distinction, is that shouldComponentUpdate ran before. You see it was giving you next props. And this one runs afterwards, which I think is okay. So after every single render, we are putting in, we're taking in the dependencies for whether we should update or not, which depend on and count. And then we're saying, you know what, if it is on, if on has changed, and or count has changed, I guess, then we're gonna set the shouldUpdate to a new number. We're gonna increment it, and then that shouldUpdate number that's always incrementing when only we say it should, we're putting that into the dependencies, the change detection for the memoizer here, that's recomputing all the expensive things. And then we're putting the expensive things right here on their own. So if I turn this off, I can increment as much as I want. And in fact, I want to know the count right here. So I'm going to put the count right here just because I want some feedback that's actually
Hey, you're here.
Hey, Joe. Live streaming.
Oh.
Say hi to everybody.
Hi, world.
Yo, yo, yo. So you can see I'm incrementing the count right here. And this is updating, but then if we turn this off, the count's incrementing, but it's not updating. But as soon as we toggle it back on, it updates. That's pretty sick. So I feel like, I think I would feel okay with this right here. Like, it's not necessarily a top level lifecycle for should component update, right? But I actually think it's better because now we can always be rendering we can always render the like the non-expensive parts of our component right here. But then if we know that a specific part of our component is going to be expensive, we can create memoizers and effects to determine whether we should update it or not. That's pretty cool. Like, we could create a couple of these if we wanted. Like, we could have a component that has 4 or 5 expensive things it's doing, and we could memoize on each one so that we're optimizing for each individual use case. And the things that only need to update will update. Whereas before, if we wanted to do this, if we wanted to always be rendering this, but then things was expensive, we would have had to put things into its own component, and then in that component use shouldComponentUpdate on the class instance. And I actually like this better. It's almost like, you know what? What if it was like this? Like, you could even have it could be a function that's like generate things, and you're passing in the count, or it could even be just a whole nother component where you're saying things count. So what this does is it gives you, the renderer, like from our perspective right now, we as the renderer have control over when we want to do expensive things, instead of the control being inside of the component that does the expensive thing. In fact, it's very similar to the way suspense is inverting control of placeholders and loading. It's inverting that suspense control to the renderer instead of having that logic live inside of every component that could technically suspend. It's really neat. So as you can see, this is an expensive component. It takes forever, and we can turn shouldComponentUpdate on or off for that specific part, and works great. I feel like I would use this in production, absolutely, and I feel like it's very similar to what they're doing here, right? Except for what they're doing is they're memoizing individual children based on just a prop. And I feel like once you bring in state, and especially if you have like a toggle, then it might get a little more complex, but as you can see, not too much more complex. I don't even know if there's probably an easier way to do this, but guess what? This works. It's like I have a shouldUpdate UID, and I'm incrementing it when I know things need to change. So this has been really fun, actually. You can tell I really love memoization and hooks. Man, it makes everything so much easier. So I hope you guys enjoyed this little video about trying to use memoization and shouldComponentUpdate and functional components. I think it's better. I really do.